I'm back, okay? So now I'm back. I know you guys are like waiting. You can't wait to see how Hardy Weinberg works, where we're doing this p squared plus 2pq plus q squared is equal to 1. Now, I already just explained to you in the last lesson the assumptions we make when we use this equation, that we're using this equation with the assumption that the population is not evolving. We're assuming that the allele frequency of the population stays the same. There's no alleles entering or leaving. There's no mutations happening. Those things that I just explained, right? Plus q is equal to 1. So these are the two formulas that I gave you, okay? So just to recap, this is the individual allele frequency, right? So we're just talking about like the individual chromosome and the allele that they carry. And this is to determine if you're heterozygous or homozygous dominant or homozygous recessive. Okay, so the questions that they're going to give you look like this, okay? So if the allele frequency of brown eyes is 0.8, right? What is the frequency of blue eyes? Okay, and that's the kind of question that they're going to give you. Okay, so this is telling you, hey, if the allele frequency, so they're talking about the individual allele frequency, they're talking about this. You got to use that equation, right? And then they can even say, okay, and then what percentage is homozygous recessive? Or it could ask, like, what percentage is heterozygous? And what percentage is homozygous dominant? Right? So, really important that we understand, right, what these two equations represent. So they're saying if the allele frequency of brown eyes is 0.8, what is the frequency of blue eyes, okay? And because they're asking for allele frequency in particular, I use this equation. So I know brown eyes is big B, right, is 0.8. Okay, if brown eyes, okay, if brown eyes is 0.8, then what is blue eyes? What would be the frequency for that? Well, I know that P actually represents the big B allele, and that Q represents the little b allele, and together the big B plus little b should equal 1. So if big B is 0.8, then what is little b? Oh, it's 0.2. Because 0.8 plus 0.2 is equal to 1, right? And so here, I now know that the little b allele is 0.2. So now I know that the frequency of blue eyes is 0.2. I now know that. That's how easy it is, okay? And then when it asks you what percentage is homozygous recessive, heterozygous, or homozygous dominant, okay, well, once I know that information, once I figure this out, once I know P plus Q is equal to 1, and I assign the numeric values that P is big B, right, and little b is Q, and I give these values, I can actually plug these values into this equation, okay? So when I have P squared plus 2pq plus Q squared is equal to 1, well, what's P squared? P squared is big B, 2pq is big B, little b, and Q squared is little b, Okay, I told you guys in the last lesson that this is actually homozygous dominant, this is heterozygous, this is homozygous recessive. Okay, so if I want to calculate what percentage of the population is homozygous recessive for blue eyes, which is little b, that's blue eyes, I just go, okay, little b is 0.2, right? 0.2 squared will give me the answer for how many in my population is homozygous recessive. So I go, hey, 0.2 times 0.2, and the answer is 0.04. Okay, you can times that by 100%, and here, 4% of the population has blue eyes or homozygous recessive. And then if it asks you, okay, what percentage are heterozygous? Okay, well, heterozygous is represented by this part of the equation, 2pq. Okay, so then I go 2. Well, p is equal to that 0.8, which is big B. Q is equal to 0.2. And there I can calculate what percentage is heterozygous. So I go 2 times 0.8 times 0.2, and I get 0.32. Or hey, now I know that 32% of my population is heterozygous. And then if I want to calculate what percentage is homozygous dominant, I just go, hey, P is equal to 0.8, right? Like that's what P is equal to. And so I go, okay, 0.8 squared. And then I go, okay, 0.8 squared. And you do it on your handy dandy's calculator, is equal to 64% or 0.64. Hey, 64% of my population is homozygous dominant for brown eyes. 32% of my population is heterozygous for brown eyes. And hey, 4% of my population is homozygous recessive for blue eyes. And that's how I use Hardy Weinberg, okay? So I'm going to give you another example to help you guys out. Okay, so what if they ask you, okay, what if they say 32% of people in a population are blue eyes? What is the frequency of the blue-eyed allele? Okay, so what if they give you something like this? Okay, well, it says 32% are blue eyes. Okay, so I know that P squared plus 2PQ plus Q squared is equal to 1. I also know that P squared represents anybody who's homozygous dominant. This represents heterozygous. This represents homozygous recessive, right? So if 32% of the population are blue eyes, that means 32% of the population are little b, right? Because in order to have blue eyes, right, you need to be little b. You need to get a little b from your mom and a little b from your dad, right? Okay, so you guys know that Q squared is 0.32, right? 32% of the population is Q squared. And so what you do is you square root that number, okay? If you square root 0.32, so second function 0.32, guess what? So Q squared is equal to 0.32, square it, and Q is equal to 0.565. Okay, so what did you just solve there? Well, you just solved that little b. You just solved that little b is equal to 0.565, right? And so now that you know this, you've just calculated the frequency of that blue-eyed allele. The individual allele, you just figured that out, okay? And sometimes they give you questions like this. They'll be like, 2% of the population has a recessive disorder. What percentage of population is heterozygous for this trait? Okay, well, 2% of the population have a recessive disorder. Okay, well, 2p squared plus 2pq plus q squared is equal to 1. Well, 2% of the population express this disorder. That means 2% of the population must be like little a, right? Where you actually see the disorder. And the only way you see the disorder, okay, is if you get one from mom and one from dad. They both give you it, and so now you can see you have the disorder. All right, now they're asking you what percentage of population is heterozygous, okay? So they're asking for the 2PQ, which is basically big A, little a. That's what they're asking. That's what they want to know, right? Okay, well, I know that Q squared, okay, this is Q squared, sorry. I know that, okay, Q squared, just going to erase this. Q squared is equal to 0.02, which is 2%. I already know that. If I square root this, okay, 0.02, oops, I get Q is equal to 0.14. Okay, so now that's the frequency of the recessive allele, right? Now, I need to solve for heterozygous, I need P and Q. I need both of these. Well, I know Q. Can I solve for P? Of course I can, because I know that P plus Q is equal to 1. If I have Q, which is 0.14, then of course I can solve for P. I'll go 1 minus 0.14 gives me 0.86. Now that I have found both Q and P, I can solve for this, right? And now I can figure out how many people in my population are heterozygous for the trait. So then I go 2 times 0.86 times 0.14, and here we go. 0.86 times 0.14 times 2. Hey, 24% of my population is heterozygous for the trait. And then, of course, you can calculate how much of your population is homozygous dominant normal by going 0.86 squared, right? And then if you go 0.86 squared, 0.86 times 0.86, you're going to get 74%. So now you've calculated that 74% of your population is homozygous dominant, big A for the, right? And they're normal. And you're calculated that 24% is big A, and that it gave you that 2%, right, have the actual disorder, which means you got to inherit that from both parents, and that's how you do Hardy Weinberg. Okay, I hope that makes sense. Like, sometimes they're going to trick you. Like, the trickiest ones they're going to give you is like, I don't know, there'll be like 5 out of, I don't know, well, let's go 15 out of 32 people have brown eyes. What percentage is homozygous recessive in this population, right? Because we're dealing with population genetics. We're not dealing with like, I get it from my mom or dad or whatever, right? Well, when you know that 15 out of 32 have brown eyes, well, you don't know if they're big B or big B, little b for brown eyes. You don't know that, right? They don't give you that, right? 15 out of 32 could be either that or that. Like, I don't know. I have brown eyes. I don't know if I'm homozygous brown or heterozygous brown. But what I do know is that 17 out of 32 are little b, little b. I know that, right? So I go 17 divided by 32. Hey, guess what? 0.53 are little b, right? That's how much are little b. I can square root that to solve for little b, right? So I can square root that. And I get, hey, little b is equal to 0.73. Okay, that means I now can solve for big B, right? If little b is 0.73, then big B is P plus Q is equal to 1, right? If little b is 0.73, then 1 minus 0.73 gives me 0.27. Now I have the individual allele frequency, okay? You can't square root this number because you don't know what percentage are this. You don't know how many of the 15 are big B, or how many of the 15 are big B, little b. You don't know, right? You just know 15 have brown eyes, but you for sure know that 17 out of 32 have blue eyes, okay? For sure you know that. So you use what you know for sure, you square root that number, and now that you have big B and little b, you can now solve for which percentage is homozygous recessive, right? And you can even solve for heterozygous or homozygous dominant, because you can put these values into the p squared plus 2pq plus q squared is equal to 1, right? Once you have the individual allele frequencies, which is the p and the q, you can substitute those in and you can find what percentage of the population is homozygous or heterozygous or homozygous recessive. Okay, I hope that helps. I gotta go. I'm at 15 minutes. Okay, take care. Bye.